Hey folks, welcome back to video 2 on the 1971 CB750. Now this video is basically going to segue right into, or was going to segue into just running the bike with the carburetors done just the way you saw them at the end of video 1. I'm going to have to bring you down here to really kind of explain this, but you'll understand here in a sec. So come on down here and I'll show you. Okay, so this is number 4 carburetor body. You can see that I have a vacuum nipple on it. You said nipple. And all the other 3 carbs have them as well because I did have this bike running. And like I said, I want to show you the clips, but they may not be relevant. Because why? I may not be able to save this carburetor, which needs additional machining. And actually, I need to do some touch-up machining on the other 3 as well. But let's concentrate on this first.
Here's how it ran with the carbs in the condition that you guys saw them.
I turned it off for a while to set the fan up. Started it back up.
No matter how much I tried, no matter what I did, this engine just ran like crap. And if you're thinking it, I already checked it. Timing is spot on and the compression is excellent. Now back to reality.
Because if this fails, what I'm going to end up doing is I'm going to have to scrap all these and I'm going to have to just get another rack off eBay. Now these are 657B carburetors. That's what's stamped on them. They are an appropriate number stamping and carburetors for this year range motorcycle as far as CB750s go, 69 to 76, okay? So these are the right ones. Other ones are 7As and something else, I can't remember which. And I'll show you the chart here that kind of identifies that from HondaChoppers.com. I'd really like to save these carburetors, but there is a couple of 7A sets on eBay right now that look okay, but are they any better than this? You really don't know. And we may end up having to roll the dice on one of them, like $375 to $500 for a rack, depending on which one you choose. So I'd kind of really like to save this. Now, what is the problem with number 4? The pilot screw threads are stripped out. This happened while I was trying to change the pilot jets in situ. So you can pop the baskets off. There's plenty of room to go underneath there after you take the float bowl out, and then you can change jets. I was fiddling with some main jetting too, because jetting that I put in based on what the service manual says is incorrect for these 657Bs. But I'm not going to get into that right now because we may not be using these. So let me just show you the problem at hand. This is actually a Cahin jet. The original 40s that came out of it, Cahin's got the Cahin little stamp on it. If you go to put it in, it just there are no threads left. It's the only carburetor that it did it on. The other 3 carburetors have excellent threads where this is concerned. I don't know what happened. Whatever came off of when I went to put this jet in, because I said, let me switch out to the Cahin ones. I didn't realize these were actually Cahin branded. And it just a little tiny bit of the threads came out, so partially they were gone already, I think. Somebody stripped them out, or the corrosion, the corrosion monster got in there, I don't know. But either way, either we fix this car body or we replace them all. I do have an idea how to do it, which is why I'm doing this in the front end of this video, because if this is successful, we'll bring you back to those clips that I was running the bike previously before this strip thread thing occurred. And then I'll show you just those kind of briefly, to give you a comparo. Because if we can fix this, then we'll change the main jetting around to where it's supposed to be, which hopefully I'll get to later if it's applicable. Because the different carburetors you can get for the first years of the CB750 take different main jetting. That's the reason why I'm really not going into it too deeply right now. I don't know what carb bodies we're going to ultimately be using. So let's get right to work on this. I have an idea on how to fix this, and I'm going to have to modify an end mill to do it, and it's kind of complicated. I'm going to go ahead and get it set up in the vise first, bring you back down here, and then we'll discuss how we're going to do this, if we can do it at all. This is probably going to be one of the most challenging small item or carburetor repairs that I've ever done on this machine. combination with the lathe work. So wish me luck and bring you back down and again show you the details on the plan. All right, I think I have you in a pretty good position, sort of on top but on the side. One of my favorites. Yes! Anyway, here's the hole in question, the stripped out threads for the pilot or slow jet. Now we aim to do in this is we aim to please. And I don't know if we're going to please anybody. But we're going to take this end mill, which is a 5.5 end mill, millimeter end mill, and we need to grind back some. I don't exactly know how I'm going to do it. I just need to provide some relief back here so we can actually get straight down on top of that little boss right there for this slow jet. Let me turn your light on so you can see better too. It's kind of a dark, dingy day out, so I don't have good ambient light coming in through the open overhead door, but this may be better. So we need to come directly down in like this. We need to be exactly, and I mean exactly, straight on this hole. There is a reduced diameter quite a ways down inside this hole. If I come in around the backside here and give you a classic reach around, this is essentially where it is down in here. And that is where the smaller part of this jet goes. The tip of it, just a tip and just for a second. There is not much clearance in there. And if we are off substantially to one side or the other when we plug this hole and eventually tap it out, we're not going to be able to get that jet in very easily because of that tip not lining up with the dimension down below or the diameter down below it. I don't really have anything to measure this hole with as well after we put this 5.5 millimeter end mill down in there to the appropriate depth, which will probably be about right here. There is obviously you can see that there is an access port right here. This is what they plugged to make a drilling to go through and go all the way to the back, because that's the inlet side. That's where the connection is for the air jet for the slow circuit. We don't need to deal with these at all, but there is a little open cavernous area, if you will, inside here before that small diameter that the tip goes into. Just a tip, just for a second. It will be able to go down basically into that area, and that's it. Because if we go any further, we're going to end up putting the plug in too deep and it'll actually plug this off. Then we have to open this up, drill it through. It's going to be a pain in the ass. So I'm going to make an estimation based upon what I see, how deep to go with this counter bore with this 5.5 millimeter end mill. And then once I do that, we have to machine a brass plug that is a fairly firm type of press fit with some Loctite 638 into this hole. Now the general rule of thumb for press fits in Imperial is 1/1000 per 1 inch of diameter. Obviously 5.5 millimeters is pretty small, and I could do the math, but the press fit probably is going to technically require about 3/10 to 5/10, and that's what I mean by that. That is going to be enough of a press fit for a diameter that size. And we have to hit this, and we have to hit it right. If I don't get this right, and that thing does not go in and thread in straight and go down into where it needs to go, then it's all over with, and we're going to order those 7A carbs or something similar from eBay and start over from scratch. This is why this is up front in this video, basically. Also, one of the problems I can see is a similar problem we had with the seats on the floats. This area is a little chowdered up on all 4 carbs, so they really need to be touched up anyway, because I don't think the jets were really sealing too well on that surface. One of the reasons why they didn't want to stay tight, because I noticed that the ones that were in there when I originally took them out were loose. These are those jets that I took out. So in concert with doing this work on this particular carb, we're going to be touching that surface off because we're going to make that plug long, a little bit longer than necessary. And then we'll bring it down with like 8 millimeter extended reach end mill or something like that. And then what we'll do is we'll just touch up this surface, you know, when we flatten that out basically. And when we do that in this one, we're going to end up having to do that on the other 3 as well, at least touch up that surface. So that's the plan at least. Whether it works or not, I don't know. We're going to have to find out. Let's get on to the first thing, which is going to be figuring out how we line up on this hole. Okay, we're going to be working in a drill chuck. In this particular one, it had a significant amount of run out. It was never designed for high precision. So I ended up just chucking a 1/2 inch end mill into it and then using the chuck on an end mill chucked in the lathe, and then cut down the shank so it's concentric with the center of the chuck of the jaws here, you know, on the Jacobs chuck. Did the best I could and got it running really, really true. I was really pleased by that. Now this is a number 45 drill bit, which I tested. It fits. It's obviously backwards, but it fits down inside that deeper hole, which is what we're going to use to line this up. It's running out a couple thou. It's close enough. This is 80 thou, the tip of this, okay? And the hole is about 83 or 84, so it's not as close as I originally thought. We do have a little bit of wiggle room, but I want to be dead nuts as possible. All right, that drill bit in reverse wasn't working out, and it's obvious to see why. I just couldn't get it long enough, and it couldn't get true enough. I turned down an aftermarket slide needle that was about 20 thou bigger than what I needed, around 81 thou to get down inside there. This is like 80, it's 81 and a half, maybe 82. I turned this one down to about 81, and I'm back on 0 now where I was with that drill bit. I'm going to see how this thing feels. This is a cool way to do it too, I think. We'll take some blue maca. Let me turn the frequency down a little bit. All right, then we go down inside. That should tell us where we're hitting. I only see it right there on this, let's say, 8 o'clock position. Try it again. I don't see it hitting anywhere. Let's extend it out even more. And now we're hitting the bottom. I can feel it. Knock the bottom out of it, baby. I don't see any blue coming off it. I'm confident that we are really, really close to dead center on that. So, 0, 0. And we're going to lock everything. Make sure it stays on 0. I mean, we can only do so much with this equipment. All right, so we're 0, 0 ready to go on this part, and I think I got enough height to do it, but let me go modify that tool, and then we are going to take a stab at this. Ow! That hurt. Okay, now I realize I have not talked about how I'm going to make the threads or what these threads are, these guys right here. I will do that in a minute because I'm working on this part first. We're going to hopefully and successfully be able to bore this out accurately and cleanly with this 5.5 modified, now extended reach end mill that I've already gotten the Z top on as far as in the DRO, so it's zeroed out here. And then we'll talk about the rest of it later. What's the point if this doesn't work? Ultimately, if we can get this thing pressed in, you know, a brass piece made to the appropriate spec, we'll use the mill quill here to do that. As far as depth goes, I'm going to just mimic the depth of these threads here. So it's 160 thou is what we're going to target for a depth. And see what happens. We'll use the fine feed as we usually do and typically do in this situation. And if it scraps, then we know where we need to go. We need to go and get another whole rack. Probably should have done originally, but I put so much work into this one already. I really wanted to try to save it as much as possible, you know, because I don't want to waste all that work. That's pretty good speed, 580. We'll just leave it there. I got everything tight. See how it looks as we start to cut. Let me get a little bit of lemon juice here. Why not? And we'll get the air compressor ready, or the air nozzle rather. So we're gonna have to blow this out as we go. I don't want to go too deep. I want to leave a little step.
Any chatter is from the fact that I'm using an end mill and a drill chuck, which is really a no-no, but I don't have a choice here due to space limitations.
End mill in a chuck. End mill in a chuck.
Oh no.
Oh no! No! God, please, no! No!
Slow it down a little bit. Yeah, a little faster is better. Okay, we're at 50 thou right now. Let's go take a look at it. Yeah, that's what I had in mind. It's got some sidewall. Okay. Estimated at a 5.5 millimeter end mill. $60. $70. Stop at 80 and look at it. Yep. It's kind of cool. As long as nothing moves and I don't do something stupid. $90, $100. Let's go to $130 and take a look at it. Coming up on it right about now. Whoops. You can look down in there with a light. Yeah, we're getting pretty close to that cross hole. I'm going to leave it right there. I estimate there's probably 25 thou of shoulder at the bottom of that left. Above those threads in this hole that goes across this way. This is the one I'm talking about. This one here. That not that hole, but that circuit. I think that's going to be fine. That's deep enough. We know we're at 130 thou, so that's fine. And that's it. Now it looks almost like the bottom edge of that hole is radiused, but it's not. It's an optical delusion, because you can see the end of that end mill is. It's a flat-ended end mill. It's fairly new, actually. Now it's not. It's just a reflection down inside there that looks like that. Let me see if I can get zoomed up this way. That's better. So you can see those threads remain just a little bit on the back side. About 11 o'clock on your screen. Yeah, we're going to go ahead and, whoops, hit you in the head. We're going to go ahead and just leave it. Like I said, I'm tripping on shit, damn it. Tell you what, there's too much crap laying around this place. Vacuum cleaner. I have to vacuum up so much. I'll just leave the damn thing out. All right, get this cutter out and got to go over to got to head over to the lathe and make a plug for it. Okay, I moved the X so we can get at this, but just in case FPL decides to give us a problem when we lose power, I moved it over exactly 3 inches from 0. So if we lost power right now and the DRO reset, I didn't change the Y, and all I need to do is re-zero over here and go 3 inches and we're back on center. Yeah, I'm a fart smeller. So we're going to take this small bore gauge, try to measure this. Not terribly deep enough to do a good job with it, but it'll get us close. It's a fairly good feel. Let's see what it is. It's all I have. I'm actually bidding on a pin gauge set. It's not entirely complete. 2 pin gauge sets actually in that Premier Auction Company up in Minnesota. And I got another bid in for adjustable parallels, stair adjustable parallels. Another stair at depth mic like mine, but it has more anvils with it because I'm missing a couple of them and a couple other assorted items in that lot. Okay, this is showing 217. I don't know what that is in metric. I'd have to do the conversion, but yeah, 217. Let's see how close it came. Ha, pretty good. 5.5118. There you go. It's going to get us close enough to start making a pin. I'm not going to bring you over to the lathe to do that. That is really mundane. You've seen a lot of turning on my channel. I'm just going to go ahead and make the pin. We went down 130 thou, so I'm going to make it about 150. I lied to you. 218, not 217. I misread it. It's 218. You probably saw that. So it's probably just a skosh over 5.11 5.511 millimeter 7.62. For considering this setup and that chuck and this whole machine, that cut really damn close on a plunge cut with a modified end mill that's not designed to be that long and thin. I know it's aluminum, but son of a bitch, that actually came pretty damn close. All right, folks, I'd like to introduce you to the star of the show, Mr. Plug. Say hi to Mr. Plug. Hi, Mr. Plug. Hey, Mr. Plug, say hi to the folks. Hi, Mr. Folks. No, just the folks. Hi, just the folks. Oh, shut up. Okay, so we got to get her up in there. Everything's all cleaned off. I'm just going to use like a toothpick or something and put just a slight amount of that 638 in there. Oh, by the way, this is at 217. 217 was the size that it turned out to be. I was just a little bit off with that measuring tool, so this is 217. So the hole must be about 216, 216 and a half. What I measured at, like 218 or something, so it was pretty damn close. I had to make a second one though. The first one I cut at 215, and it's obviously too small. This one at 217 is just starting to go in. There is for the size of the part, a somewhat generous radius on the bottom of it, so it clears any potential radius that the cutter did leave, so it goes right down to the bottom of that hole. And I did make it 150 long. Let me go get something and put a little Loctite on, get us back under center, and we got to do this. Okay, engage the fine feed. I've got it in position, and we got a wee bit of little Loctite 636 in there, 638. Wish me luck. Oh yeah, that went down with some decent stiffness. And believe me, I don't really remember what that is nowadays, but it felt pretty good. Now, did any Loctite get down below that? I don't know, it may have, but I have no way to really clear it out, because if I back flush that with some brake clean, well, we're gonna have a problem, and it'll probably wash it out or deactivate it. We gotta let that cure an hour or so, then we can do some more work on it. If it cures about an hour, it's going to be nice and solid. It's got a fairly decent push. Because something that I have not really discussed yet was kind of the theory behind this, which is pretty simple. We're not going to be in a position that we're going to jack the plug out of the aluminum with the threads from the jet, because that is basically the same size as the jet. We are simply relying upon the press and the Loctite to hold that in as if it was just an aluminum casting that we were drilling and tapping fresh. That's basically what we're mimicking here. And again, we're just above the surface, which is exactly what I wanted. So when we cut that off with or I should say conventionally flatten that, kind of face it off with an end mill, we'll just touch that aluminum. It'll be exactly the same height too. And since we're 0-0'd over the workpiece, we are in a position to drill and tap the hole, which is a 3.5 millimeter. That's what this is as far as I can measure it. 3.5 millimeter by 0.6 thread pitch. I have no such size tap or a thread pitch tap yet. I ordered a set of 3 from McMaster Carr that is a valid size and pitch for a metric tap, 3.5 by 0.60. That's the best measurement I can get off of this using the calipers here, converting over to metric. I just put the jet in a vise and then use a magnifying glass with a thread pitch gauge. 0.6 fits the best. And my eyes are just not that great to really zoom up on it like that, but it looks like it's right. So we're going to let this sit, mill it, and then we'll let it sit longer until our taps come in. I've already looked up the tap drill size for a 3.5 tap, 0.6 thread pitch. I don't remember what it is, but I can use a standard numbered drill bit for that. So far, I'm liking what I see. Okay, it's been like 3 hours. Now, theoretically, or not theoretically, but according to the product's website, it takes longer to bond to aluminum than steel, so you're supposed to wait more time, but guess what? We're not. if I knock it out with this end mill just taking skim cuts, it's not going to hold under any other circumstances, even at this point, even if I waited until the next day. So if we knock it out, then we know we got to just get the other rack. So at least, you know, it's kind of like riding a motorcycle. When in doubt, gas it out. It may not solve the problem, but it ends the suspense. Let's go ahead and end the suspense. So it's a 10 mil solid carbide end mill in a collet, the way it's supposed to be run, not in a drill chuck. Just want to dust it off a little bit. Wow, solid carbide does just such a nice job. Okay, that just took a little bit of the top of the aluminum, but we are there. Boy, those cutters just work so nice. Okay, yeah, the camera didn't want to autofocus at that particular point, basically because it's a little bitch. Okie doke, back on 0, and we are set to center drill this with the table locked, both axes. We're just going to put a little center drill in. The tap drill for an M3.5 is 114 thousandths. This is 115, which is a number, I think it's a number 32, but I did measure it with the caliper, so it doesn't matter. We'll dab a little bit of lemon juice on here. Why not? Not to quite. Yep, that looks good. I'm just going to double check, make sure I didn't screw up. This is actually 115 thou. And so it's thou bigger, that's okay. Send it. Yep. What I felt to do was go down into the existing threads and just touch them. I could hear it. Now we gotta blow all this out in here when we get done, but we'll get it out of there. I'm gonna use a slightly larger center drill just to give it a little chamfer. Now, tapping it. I haven't figured this part out yet. Okay, the taps came a little while ago, so that's why I'm doing this now. I gotta be honest with you, that hole almost looks like it's big. But I triple checked this. That is the tap drill size for this, number 32. So we're gonna go in by hand, put some gentle pressure on this, just to get started straight. Yeah, that's enough. Now we're going to disengage the chuck. If I back the jaws of the drill chuck off, I can actually slide this thing over to the side and have it clear. Otherwise it wouldn't. Yeah, can't bake everything into the pie, you know, or into the cake, as the case may be. Wow, clearance is clearance. That just barely fit. I bet you it was 10 thousandths there. I got a feeling that drill cut big. I just do, the way it feels. Of course, they are high-speed steel, brand new taps. But I would think that it would be a little harder than that. Okay, that's it. I think it cut big. Well, it took a chip. Not much of one. Looks like we got the thread right. I don't want to rail on it though, because the Loctite's not fully dry or cured. I like to give it a little snitch though, you know. Not bad. I can get that pretty tight right now. Yeah. Not bad. Let's take a look at it from a more vertical aspect so you can kind of see at least somewhat of the threads. I mean, they certainly look like they're well developed. And I know that was the right drill, but did it cut a little bit big? Well, it's 1/1000ths big, but you know, I think this is going to work good. I really love, look at this. I mean, see how the brass just seamlessly blends into the aluminium? I think that really shows that we got a pretty good press on this. There is no space there whatsoever. And with that Loctite 638, I just don't think that that is ever going to move. I think it's going to be another good repair, to be honest with you. I think it's going to work. Okay, we'll end right where we started, in the same aspect. A fat guy next to a clapped out milling drilling machine talking to you guys on camera. Might as well take these guys off, huh? Anyway, that's a good repair. I feel real confident with it. The way that there's no seam at all around that plug I put in after milling it is really telltale. That's a really good fit in there. And I'm confident that with that Loctite, it's just not going to go anywhere.
That's bullshit.
But it didn't work. It sort of worked. But when I went to tighten it up, it just spun in that bore. And I was able to pull it out without too much drama. Big fail. But I didn't give up. Let me bring you back down and show you what it did. Well, I figured I'd use that step that's inside there, that little shoulder I made, to my advantage. So I calculated out the tap drill size for a 1032 thread. And it's just smaller than that bore that this thing got pressed into. But it's not big enough where it's going to take all that step out. So I sent that drill bit down through after lining it all back up again. No big deal on that. And then put a 1032 tap in, just a certain amount, you know, maybe about 2 or 3 mil depth, 4 mil tops. And then I went back over to the lathe, and since I had a piece of that exact size still remaining on that brass, all I did was put it back in and extend the depth or the length of it a little bit because I needed a little bit more length. Then took it and figured out what my major diameter was for a 1032 thread. Then I found a 1032 nut. So I turned down the major diameter for 1032 on that brass end. Pretty long because I need something I can actually see when I thread. Then I just single pointed the 1032 thread in that little end. No big drama. I had the nut as a gauge. So once I made enough cuts and the nut went on okay, I cut the threaded part down to length. I figured if I put a 1032 screw in with some Dykem on it, it would kind of give me a witness mark on the screw. And that would be the depth that I would want to go, because naturally the tap drill, size for a 1032, I didn't plunge the thing all the way down in. I would have taken out that reduced diameter down there for the tip of the jet. Turned it down or faced it down to length, deburred it, and then put a slot in the top for like a screwdriver. And give it a quick test fit. It started to bind up nicely. In other words, the threads are pulling it in. And that's what I did after I put some Loctite on it. I put a little bit more Loctite 638, twisted it in, and then ended up using a little pair of pliers to give it an extra bit of torque. And that's where we are today, right now. This is only minutes after I've done this. And we're going to wait a while, a couple hours or so. And then I'm going to do the same operations off camera. We'll drill and tap the hole again for the M3.5 by 0.6 thread pitch, but I'm going to go a little smaller on that tap drill this time because I just didn't like the way it felt, as far as cutting a little bit big. Going to go like 1 or 2 sizes down on the numbered drill bits for that. And then we'll tap it, and I think that will hold the jet even better. There ain't no way that this is going to come out now with a thread in there. What would happen was when I tightened it, it spun, loosened it up, and that was it. Then I couldn't even unscrew it. I had to take the insert out. I had to take the plug out. But there's no way it's going to happen now with a thread in there with Loctite. I've got a lot more surface area with that thread down in there. I don't like to lose, and I don't like to give up, and I think this is going to suffice. Here's Mr. Plug. You met him earlier in the video. Mr. Plug's going to say goodbye now. Goodbye, Mr. Plug. Goodbye. Sorry it didn't work out. I mean, seriously, whose idea was it anyway to put a shallow plug like this into a casting like that just with Loctite and expect it to hold up? That would be him right over there, the fat guy by the lathe. What are you calling fat? I thought it would work. So we'll bring you back when this is done. I'll show you the final product, but I don't think we're going to have any time in this video ultimately to do those clips. That's all the clips of it running, even before and after. I gave you a little kind of teaser earlier in this video of how it ran so you get an idea. We just don't have the time. This video's getting too long because I really wanted to show you the lengths that I will go to pull my hair out, whatever's left, and fix these carburetors. That's about as tight as I can get it. No problem. We are good. I sure as hell hope none of the other 3 strip out. They seem okay. If I got to go through this times 3 more, it may actually go pretty easy now that I know what to do, but the thing is I really don't want to. So we'll wait for a 3rd video. We'll just do all running. There won't be any other of this bullshit unless it's relevant. Because actually I'm still waiting on parts anyway. I'm waiting on that little flapper for the choke on this particular carb. And I'm waiting on a few other bits as well. So I really kind of need those before I put these back together anyway. I want to get this video out before I have another pair of videos coming out on that ZRX12. Those are all done. They're actually uploaded to the channel and scheduled for a future date and time. But I want to stick this one in before that because it's closer to the video 1 on the CB750, so it's not confusing. Just the way it is when you're doing YouTube, yeah. Sorry I didn't do any more clips, but it is what it is. I hope you enjoyed this, got something out of it. I am definitely crazy, there's no question about it, but crazy in a good way. So I hope you're crazy too. If you want to see more of this junk, you know what you need to do, stick around. Thanks for watching. Don't just repair, restore. We'll see you on next videos.